So today it's raining here at Woodbury. So this is Friday, October 28th, and it's raining out. Rain happens when our atmosphere, or the air around us, becomes saturated with water vapor. And once it becomes saturated with water vapor, that means it can no longer hold any more water vapor, which is water in a gas form. So therefore it rains. Sometimes you can get fog instead of rain, and we'll be looking at fog later on this year. We're going to talk about what happens and how the atmosphere becomes saturated over the next couple of weeks.
Humidity is how much water vapor is in the air. So water vapor is water in the form of a gas. When we have liquid water, we call it water, and then when water freezes, we call it ice. So water vapor is the name of water when it's in a gas form. And you breathe in a little tiny bit of water vapor as you inhale, because we have water vapor in our atmosphere. Evaporation relates to humidity, because in order to get water vapor in our atmosphere, we have to have the process of evaporation, which means that liquid water will heat up due to the sun's energy and then turn into water vapor or water in the form of gas. So evaporation happens all the time around the world, and it contributes to the water cycle that we'll be talking about later on this year. The warmer the air, the greater amount of water vapor can be present. So as the air heats up, kind of like in the summertime, it can get really humid out, because the warmer that air is, the more water vapor can fit between all the other air molecules. So more water can evaporate because the temperature goes up, and that means more water vapor can fit in the air, which makes it feel like it's really muggy, which kind of leads to relative humidity. And relative humidity is how humid it feels to us, okay? So when we're in the afternoon on a hot summer day, the end of July, beginning of August, and it's really muggy out, and we just feel hot, sticky, that's sort of what we call relative humidity when we talk about humidity in those terms. And the reason that it feels so yucky on those days is because the sweat can't evaporate from your body, which is a form of a cooling mechanism that humans have. When we sweat, the sweat can evaporate, and then we cool off. But when it's hot and humid, there's a ton of water vapor in the atmosphere already, so no more water can evaporate and turn into a gas and fit in the atmosphere, because there's already too much water vapor in the atmosphere that the atmosphere cannot hold it anymore. So when the atmosphere can't hold any more water vapor, we call it 100% saturated. And that's when we start to produce clouds and fog. And once those clouds get too heavy with water vapor, because clouds are when water vapor condenses or turns back into a liquid, those clouds get too heavy from it, then we get rain.
In order to figure out how much water vapor is in the air, we look at relative humidity, and that's sort of how humid it feels. Even on a rainy day, that would be 100% saturated, so it would be 100% humid. We use something called a synchrometer to measure relative humidity. There are two thermometers on my synchrometer. One has a wet bulb. This one has filter paper that's wet over one of the bulbs of the thermometer, and the other side is what we call the dry side. So we swing it around for about 30 seconds to a minute, and then we record the two temperatures from both thermometers. And we can do a couple simple calculations and look at a data chart to give us relative humidity. And relative humidity is kind of what it makes us feel like on a day that is humid. So in the summer, when it feels hot and sticky out, that means the humidity is high. But if it's dry and we don't feel as sticky and it seems slightly cooler, although the temperature could still be high, then it's a less humid.